Your MCP server system configuration shouldn't be hard-coded. It should adapt dynamically to your application's needs. We'll fetch a pre-configured system prompt using getPrompt, passing in role and expertise arguments to generate a tailored AI assistant setup. You'll see how the server returns structured messages ready for immediate use in your LLM workflow.
Async with client. Result equals await client. GetPrompt, system configuration. Role, helpful assistant. Expertise, Python programming. Hash typically returns messages with role equals system. System message equals result. Message is 0. Print F system prompt. System message content.
This demonstrates the prompt template pattern for generating dynamic LLM interactions. The concept treats prompts as reusable message factories that accept arguments to produce customized conversation sequences. What makes this distinctive is the separation between prompt definition on the server and prompt usage via client, enabling consistent yet flexible LLM interactions across different contexts. The pattern works through declarative composition, where clients request prompts by name and provide arguments, while servers handle the rendering logic. FastMCP automatically manages argument serialization and message formatting, allowing clients to work with native Python objects while ensuring MCP protocol compliance. This creates a clean boundary between the client's intent, what messages to generate, and the server's responsibility, how to generate them. This approach solves the problem of prompt fragmentation and manual message construction in LLM applications. By centralizing prompt logic on servers, you eliminate duplicate prompt code across clients while maintaining version control and consistency. It's particularly valuable in multi-client systems or when prompts require complex argument handling, though it does introduce a network dependency for prompt resolution. Let's break it down line by line.
Async with client.
This uses Python's async context manager pattern. The async with ensures the client connection is properly initialized and cleaned up, preventing resource leaks when the block exits. Critical for async operations where manual cleanup would be error-prone.
Result equals await client. GetPrompt, system configuration.
This fetches a pre-configured prompt template named system configuration from the server. The dictionary parameter dynamically injects role-specific variables, enabling prompt customization without hard-coding values. This is the standard pattern for retrieving reusable prompt templates in FastMCP.
Role, helpful assistant.
This defines the AI assistant's role as helpful assistant, setting its behavioral context for the conversation. The role parameter determines how the AI should respond, with helpful assistant being a standard configuration for general-purpose assistance.
Expertise, Python programming.
This defines the AI's expertise domain as Python programming. It constrains the system's responses to Python-specific knowledge, preventing off-topic answers and improving relevance for coding assistance. This closes the dictionary argument passed to getPrompt. The trailing brace completes the configuration object, which defines the prompt's role and expertise parameters for the AI system.
Hash typically returns messages with role equals system. System message equals result. Message is 0.
This extracts the first message from the API response, which follows the FastMCP convention of returning system-level configuration as the initial message with role equals system. The pattern ensures consistent access to system prompts regardless of additional messages in the response.
Print F system prompt. System message content.
This outputs the retrieved system prompt content to the console. Debugging step that verifies the prompt was fetched correctly and shows its actual text value. Prompt engineering pattern. The getPrompt method demonstrates FastMCP's template-based message generation, where structured arguments dynamically render conversation-ready messages without manual string formatting. Arguments automatically serialize to JSON strings for complex types, but simple strings pass through unchanged. Verify your server's expected types. This pattern eliminates boilerplate while maintaining type safety across the client-server boundary.
The prompt that accepts everything must first become nothing.